Vaccines are sensitive biological substances used to reduce or get rid of the risk of contracting a disease. They are a complex mix of active and inactivated microorganisms, proteins, carbohydrates, and lipids. Of all the environmental conditions that affect the stability of a vaccine, temperature is the single common factor that needs to be regulated for them all. What this means for most vaccines is that they must be stored in a refrigerator between 2 and 8 degrees centigrade. The individual storage requirements for each vaccine, however, can be found in the summary of product characteristics. But why is the stability of a vaccine affected by temperature? And why does keeping it in the fridge increase its shelf life? Vaccines in one form or another contain proteins, polypeptides arranged into tertiary and quaternary structures, the orientation of which is crucial to their function. These molecules will degrade over time, and the degradation of the proteins will be slowed down by reducing the temperature the vaccine is kept at. Fundamentally speaking, this reduces the energy going into the system and the chance that a bond between amino acids in the protein will break. It is the bonds between the amino acids that are integral in retaining its structure and keeping its potency. So reducing the rate at which these bonds break increases the time that a protein retains its vital shape and thus its biological activity. It is particularly true for vaccines and biologicals that we must be overcautious in their storage, as measuring their potency is difficult because there is no lab test that can be performed to adequately assess their full biological activity. Having a reduced temperature also reduces the growth of any unwanted microbial contamination. It does, however, introduce the need for a cold chain, which ensures that from manufacture to administration, the vaccine is kept at the required lower temperature. This includes chilled storage in the manufacturing unit, warehouse, transport fleet, and pharmacy or clinic where it will be used. The integrity of this cold chain is vital, and if broken, will directly stop the availability of the vaccine. This is even more difficult in hot countries, particularly those less economic developed ones, where remote communities have little access to reliable cold storage, creating a large health inequality. Vaccines and other biological materials must be kept at reduced temperatures to slow down the degradation of the structure of proteins vital to their action. If you want to explore this in more detail, you can look at the World Health Organization's Storage of Vaccines reports and the Government Green Book on Immunization.